We're going to be looking at lesson 1.5. It's called the law of sines. And so far, we've used trig to solve right triangles in which we knew two other pieces of information. We either knew two sides or an angle and a side. And now what we're going to do is we're going to solve non-right triangles. We'll be given three pieces of information. And we have two different methods to solve non-right triangles. We have the law of sines, and that can be used when you're given angle, side, angle, angle, side, or side, side, angle. Now, these are important. These are the order that we find the angles and sides, so order is important here. Similar to what we talked about when we learned congruent triangles in geometry. So law of sines is for angle, side, angle, angle, side, and side, side, angle. There is one case that is an ambiguous case, which we'll talk about when we have side, side, angle. Then we use the law of cosines if you know all three sides or two sides and the included angle. So in this lesson here, we're going to be focusing on the law of sines. So here is the law of sines, which there is a proof for it that we will work on later. It says in triangle ABC, where A is the length opposite angle A, B is the length opposite angle B, and C is opposite angle C, the following proportion exists. Side A over sine of angle A equals side B over sine of angle B, which is also equal to side C over sine of angle C. Now, we don't take this whole equation at once. We just take a proportion, but several proportions work, so we can use that proportion, we could use this proportion, or we could say A over sine A equals C over sine C. Also, if we're trying to find an angle rather than find a side, we can use the reciprocal form of the law of sines. So here we have an example. It says solve triangle ABC. If angle A is 34 degrees, angle B is 76 degrees, and side A is 9 degrees round, measures to the nearest tenth. So it does usually help to sketch this out. So we're going to draw a triangle, and we're going to start with angle A and try to make it close to 34 degrees, and then you can draw angle B, and just try to make it close to 76 degrees, and then you can label A, side A 9, which is going to be opposite side or angle A. So there's a triangle. Looks like this bottom right would be a good one for angle A. And then we name our other ones. So once you sketch this, it's actually easy to see what setup we have here. So this is an angle, angle, side. Notice we have two angles, consecutive angles, and then the side that's outside of them. So this is going to be angle, side, or angle, angle, side. If we would have known side C, it would have been angle, side, angle. And so we know that we learned that if we have angle, angle, side, we're going to use the law of sines. So let's go ahead and think through this. So we're trying, when we do this, we have angle A and side A. That's what we like to put first. Now these are named A, which is fine, so it works out in our law of sines well, but sometimes it's not triangle ABC. It might be triangle XYZ, and you have to work through that correctly. But what we usually like to do is pick the angle and the side across from it that we know when we do that first. And then we know angle B, and we're going to find side B. So we don't do anything with the C's yet because we don't know either one of them. So we'll go ahead and plug those in. So we have 9 over the sine of 34 equals B over the sine of 76. And we want to solve for B. What I would typically do, instead of putting these in your calculator right away, we're just going to multiply both sides by the sine of 76 to help us solve for b. So I would do something like sine of 76 here and sine of 76 here. And so when we multiply this top, it's actually easiest, instead of doing sine of 76 times 9, we put the 9 first. But 9 times the sine of 76 over the sine of 34. That means we only have to use our calculator once to type all that in. Make sure you use your parentheses correctly when you type that in. Once you do that, you get 15.6. Make sure your calculator is in degrees when you do that. So we found that side B is 15.6. Now what we're going to do is we're going to find angle C. I know we're getting a little bit messy up here. We could have done this right away to start with because we have two angles, and we could have found the third angle using the triangle sum theorem. The three angles have to add up to equal 180. So we'll add 76 and 34, which is 110. And we'll subtract that one from 180, and we get 70 degrees. So that's angle C is 70 degrees. Now that we know that, we can use law of sines again, and this time we're going to use it to find side C. And I still like to use side A and angle A because they we knew those to start with. The 15.6 is rounded, so we're not going to use that. You could use it, and it will get you pretty much the same thing. It might just be off maybe in the hundredths or thousandths place. So we'll start again with the law of sines, but this time we'll do A over sine A equals C over sine C. So once again, we put our A over sine A equals C over sine of C. We will multiply both sides by the sine of 70. And that will give us C equals 9 times the sine of 70 degrees over the sine of 34 degrees, which ends up equaling 15.1. And so we have solved that triangle. We found B, we found angle C, and we found side C. So we found the three missing parts.